In this video, we are going to see about the central force motion. I'm sure that central force motion is a very important topic of classical mechanics. You are going to get a question from this part, that is in part C of 5-mark question. So the central force is always going to be, the force is in the format of F vector is equal to plus or minus F of r cap. That is the force is the function of r and r cap. Here the plus sign is represents the repulsive, minus means attractive. Here the gravitational force is always attractive force, and Coulomb force can be both repulsive and attractive. If you are having any particle at this position and this is the center of a circular or any of that path, you can having the force always in this direction, so that it is known as a central force. The central force have some of the features like the central force is always a conservative in nature. Conservative means the line integral of that particular path will be 0, so it does not depends on the path, hence the central force is path independent. The angular momentum of the central force motion, or we called that central force of the angular momentum, will be conserved. This is the basic things we have to know in this concept of central force motion. So angular momentum about center of force is conserved. This is conserved because the torque in this case about the center is 0. Torque about the center is 0. That's why we are saying that the angular momentum is conserved. So these are some points about the central force motion. And there is one more point that is very useful whenever we use the central force motion, in that the aerial velocity is constant. We can write that is delta A by delta T is equal to constant. Area covered in that particular time under a central force motion will be constant. So next we are going to find the relation between the angular momentum and the aerial velocity, and that is very important relation. Whenever the particle is moving in central force, and this is the center of that force, and the particle is in this position, here that is the r cap direction, and let us say this is our theta cap direction, and this is in the velocity of Vr, and this is in the velocity of V theta, and angle between these is 90 degree. What is VR? VR is equal to dr by dt into r cap, and V theta will be equal to the r d theta by dt into theta cap. That is r dot r cap, and this is this is equal to r theta dot theta cap. So V theta we know. So what is the velocity vector? Velocity vector that is equal to r dot into r cap plus r theta dot theta cap. So this is the needed velocity vector relation. Then we are going to see the angular momentum that will be equal to m v theta into r. So that is m v cross r. That v cross r will be equal to v of sine theta. The theta value for the radial vector, that is for vr, will be 0. So only the theta component will be contribute to the angular momentum. So that we can write as m r theta dot into r, that is equal to m r square theta dot. I think now it will be clear that angular momentum will be equal to m r square theta dot. This is a final expression. This formula will be used in so many numericals, so this is a very important formula. So next, to find the areal velocity, whenever the particle will be here, this is the central force O. In this, the particle will be in this direction. Let us say the particle will be here at time t, then it will be moved to that point at a time t plus del t. Now the angular displacement will be delta theta. Next, let us consider the r is the radius of that path. So this component will be r delta theta. So that is very small displacement there, that is very small time difference. So the areal velocity in this case will be equal to delta A by delta t. So what is delta A? Delta A is the area swept by this time. So area of this triangle will be half r into r delta theta. This area of this triangle will be considered for a small time, so divided by delta t, that is equal to half r square delta theta by delta t. Delta A by delta t is equal to half r square theta dot, that is areal velocity. We are going to find the relation between the areal velocity and angular momentum, that is delta A by delta t is equal to L by 2m. So L is equal to m r square theta dot. From that we can get the areal velocity is equal to L by 2m. So this topic is very very important, and this is very basic necessary topic. So finally we found the relation between areal velocity and angular momentum, that is that we can write as areal velocity is equal to L by 2m. That will be a constant value, because L is also a constant value and M is also a constant value. I think you get my point. Thank you. Thanks for watching my video, and like and subscribe to my channel for more videos.